Okay, so we'll be going over the review sheet for your test that's tomorrow. That's third quarter, third test. So let's take a look at the first thing. It says to determine the domain, which are your x values, the intercepts, and any asymptotes. So the first one is h of x is equal to the square root of x minus 8. All right, so first of all, what you would want to know is what does h of x equals the square root of x look like? Because that's the parent function. So you would want to plug that in your calculator. So you should go ahead and plug that in your calculator. And when you plug that in your calculator, it looks like this. From 0, and it goes like that. All right, so now notice that your parent function, it does not have an asymptote. There's no line that this graph gets closer and closer to and doesn't cross. It actually stops right here, or it actually starts right here at 0. It doesn't keep going. It just starts right there, or stops there, and just keeps going to the right this way. So therefore, this here, the square root of x minus 8, notice that it's a shift, right? You're minusing 8. It's a shift to the right on the x-axis at 8. So it's starting over here at 8 and going that way. So my domain would be from 8 to infinity. Or it could be written as 8 is less than equal to x is less than infinity. Like that. Okay? It could be, let's talk about the x and y intercept. So let's talk about the y-intercept. Notice that your graph is starting over here at 8 and it's going to the right. It's not crossing the y-axis. So there is no y-intercept for this graph. And look what happens when you do try to find the y-intercept. Remember, the y-intercept, x would be equal to 0. So if I take h of x and do the square root of x minus 8, and I make my x equal to 0, I would get y equals the square root of 0 minus 8, and then I would get the square root of negative 8. And that's an imaginary number. That is not on the number line, so it does not cross the y-axis. All right, however, though, there is an x-intercept. I mean, we could see it right there. So let's find that x-intercept. So remember, the x-intercept, y is equal to 0. So I have 0 is equal to the square root of x minus 8. To get rid of a square root, you square both sides. So I get 0 is equal to x minus 8. Add 8, x is equal to 8. So my x-intercept, remember an intercept has to be written as a point, would be 8 comma 0. So again, there is no asymptote. There's no line that this graph gets closer and closer to because it starts or ends here, however you want to look at that, and just keeps going to the right. All right, so let's take a look at B. All right, so hopefully you recognize that g of x here is an exponential equation, and the reason why it's exponential is because your exponent has a variable. So remember your parent function for an exponential. Your parent function for the exponential looks like this. So there is an asymptote for this one. Your asymptote is the x-axis here. But there is a shift. This is your parent function, this guy here. So there's a shift here, right? I have plus 7 to the whole y value. That means it's up 7. It means it's going up. That means it's going up here to 7. Okay? That's your parent function. That's your asymptote here at 7. Okay? So it's going like this. Okay, so at 7, it's going there. So there is an asymptote. Your asymptote is y is equal to 7. That's your asymptote. Your domain are your x values. So it just keeps going over here to negative infinity. It just keeps going up to the right to positive infinity. So that would be your domain. That would be from negative infinity to positive infinity. And now we want our asymptotes. So notice that there is no x asymptote. It does not cross the x-axis because it's not going past 7. Y equals 7 because that's your asymptote. So we will find our y-intercept, though. It does have a y-intercept. So y-intercept, x is equal to 0. So I have y equals 3 to the 0 minus 1 plus 7. So that's y equals 3 to the negative 1 plus 7. So you could just plug that into your calculator just like that. Y is equal to 22 over 3. So that would be 0, 22 over 3. All right, and again, there's no x-intercept because it's not crossing the x-axis. And even if you try to find the x-intercept, if you make the y value equal to 0 over here, make this y value 0, you'll get an imaginary number. It won't work. Okay, so let's take a look at C, the f of x here. All right, so I have my log equation. So remember, a log equation looks like this. This is your parent function. All right, so there is an asymptote for my parent function. That would be x is equal to 0. That's the y-axis. Okay, however, though, this one has a shift. See, I have a plus 2 to the x value. That means I'm shifting it to the left to 2. So at 2, I'll have an asymptote here. At 2, I have an asymptote. So my graph will look like this. All right, so I do have an asymptote. My asymptote is x is equal to negative 2. Sorry, negative 2, not positive 2. And now I want my domain. My domain, my x values are not going past negative 2, so it's greater than negative 2. That's my domain. So it would be negative 2, comma, to infinity. Or negative 2 is less than or equal to, not equal to, less than x is less than or equal to infinity. And it should not be, sorry, should not be an equal sign under there, just like that. Okay, and now let's talk about our asymptotes. So this has both asymptotes here because I am going through the y-axis and I'm going through the x-axis. It has both intercepts. So let's start with the x-intercept. That means y is equal to 0. So I have 0 equals log base 2 of x plus 2. I want to solve the log equation, so I put it back in exponential form. The base is 2. So it's 2 to the, remember these two switch. So I get 2 to the 0 equals x plus 2. 2 to the 0 is 1 equals x plus 2 minus 2. I get x is equal to negative 1. So that would be my x-intercept, negative 1, comma, 0. All right, and now my y-intercept. That would be x is equal to 0. Let me just move this. All right, so I have y is equal to log base 2 of x plus 0 plus 2. 0 plus 2 is 2, so it's y equals log base 2 of 2. This you could just plug into your calculator in log base. So I get y is equal to 1. So there is my y-intercept, 0, comma, 1. All right, so let's take a look at number 2. Okay, so number 2 says you want to solve. F of x is equal to this polynomial, and g of x is equal to this. And I want to know, when is f of x equal to g of x? So I want to know, when is my y value equal to my y value? So, therefore, what I'm looking for is, what is my x values equal to? So that my y values are equal. So I just take these two here, and I set them equal to each other, and I solve for y. All right, so let me set them equal to each other. Move this. All right, so I have x squared plus 2x minus 1 equals 87 minus x. All right, so it is a quadratic, so I'm going to equal it to 0. So I'm going to add x, and I will minus 87. So I get x squared plus 3x minus 88 is equal to 0. So you want to factor this. So you multiply the first times the last, I get negative 88 x squared. So now I'm looking for two numbers that multiply to 88 and minus to give me a 3. That would be 11 and 8 x. They have to be different signs to get a negative 88. And when I add them, combine like terms, I have to get a positive 3. So it's positive 11x and minus 8x. So it's minus 88 and x squared. Factor by grouping, GCF is x times x plus 11. GCF is negative 8 times x plus 11. So my factors are x minus 8 and x plus 11. And T-chart, we get x is equal to positive 8 and x is equal to negative 11. So that's all you have to do. You don't have to plug it in and find your y values because that's not what it's asking. It's asking when are my y values going to be equal. My y value is going to be equal when my x is 8 and my y is negative 11. All right, let's take a look at B. So I'm solving this radical equation. So let me rewrite it over here. I have the square root of 9x minus 5 minus x is equal to x. So the radical equation, you want to first isolate the radical, so you add x. X plus x is 2x, not x squared, so please be careful. So you want to rewrite your radical as an exponent, so it's 9x minus 5 to the 1/2 power. Remember, square roots of 1/2 equals 2x. To get rid of the 1/2, we multiply it by its reciprocal, which is 2/1. Raise this to the 2/1 power, which is 2. So that just becomes 1. So it's 9x minus 5 equals 4x squared. When I square 2x, that's 2x times 2x is 4x squared. It is a quadratic, so it has to equal 0. So we're going to minus 9x, add 5. So 0 is equal to 4x squared minus 9x plus 5. All right, so now we're going to factor. So I'm going to multiply the first times the last. I get positive 20x squared. So what numbers multiply to 20x squared and add to 9? That would be 4x and 5x. They have to be the same signs. They're both negative to get negative 9x and positive 20x squared when we multiply. Bring down the 5, bring down the 4x squared. And then we'll factor by grouping. So the GCF is 4x times x minus 1. GCF is negative 5 times x minus 1. So my factors are 4x minus 5 and x minus 1 equals 0. T-chart, I get x is equal to 1. Over here you have 4x minus 5 equals 0. Add 5. 4x is equal to 5. Divide by 4, we get 5/4. Now, I'm not going to do this. You guys need to do this on your own, but you do have to check these. Make sure you plug this into the original. When I say original, I'm talking about this here. Make sure it works in the original. And this does work in the original. And make sure you check this one into the original, and that one also works. So you do have to check these, because sometimes they don't work. All right, so let's take a look at C. So I have a division problem. I'm dividing the polynomials. So I have negative 2x to the third. Now notice that my next term is plus x. So what I'm actually missing is I'm missing the x squared term. So what you would want to do is make sure you write an x squared term. So just write it as 0x squared. All right, so let me move that up. So we actually want to write this as negative 2x cubed plus 0x squared, because I don't have an x squared term, plus x plus 1. And you want to hold that space so you don't forget about it. And I'm dividing by x plus 3. All right, so what can I multiply x by so that I get negative 2x to the third? That would be negative 2x squared. Now multiply down. So I have negative 2x squared times 3 would be negative 6x squared. And then negative 2x squared times x would be negative 2x to the third. We subtract. So when I subtract, this becomes plus plus, that cancels out. And then I have plus plus, and I get 6x squared. Bring down the x. So x, now we're on to here with the 6x squared. So x times what gives me 6x squared? That would be 6x. Now multiply down. 6x times 3 is 18x. And 6x times x would be 6x squared, and we're going to minus. So when I minus, those cancel, and I have 1x minus 18x is negative 17x. Bring down the 1. So x times what is negative 17x? That would be negative 17. Multiply down, and I get negative 51 and negative 17x. Now we subtract. So those cancel, and I have a plus plus. So I have 52. And then I would write this as negative 2x squared plus 6x minus 17. And then I have a positive 52, so it's plus 52 over x plus 3. Okay, so let's take a look at number 3. Okay, so number 3, I have two functions. F of x is equal to 2e to the 0.05x, and g of x is equal to 2 sine 4x. So the first thing I'm looking for is f of 3. So I'm just going to take 3 and plug it in. So I have 2e to the 0.05 times 3, which is 0.15. So that's 2e to the 0.15. Just plug it into your calculator. We get f of 3 is equal to 2.324. All right, and B, we're looking for g of pi over 6. So that's radian measure. We want to put that into degrees. So remember, pi is 180 degrees. So that's g of 30 equals 2 sine 4 times 30. So this is 2 sine of 120. So you're going to plug sine 120 in your calculator, and you get 0.8660. You have to know that conversion. So that's 2 times the square root of 3 over 2. The 2 and 2 reduce, so I'm left with the square root of 3. All right, and C, it says find f of 6. Find f of x equals 6. So I want to know, when is this guy going to equal 6? So 6 is equal to 2e to the 0.05x. So I'm going to divide both sides by 2. I get 3 equals e to the 0.05x. All right, so now that I have my base is e, and this is all isolated, I'm going to log both sides. But since it is base e, you're going to use ln. So it's ln 3 equals ln e to the 0.05x. And then this will go into the front because that's the rule for exponents. So it's ln 3 equals 0.05x ln e. Divide both sides by ln e. So you just plug ln 3 divided by ln e into the calculator. You get 1.09861229 equals 0.05x. Divide both sides by 0.05. And we get x is equal to 21.97. Okay, so let's take a look at 4. Okay, so 4 says to rewrite. So we want to write this one here, 1.035 to the t power, as a power of 4t. So it does seem hard, but it's not actually that hard. We did do it a long time ago in class. So you want to take 1.035 to the t power. It still has to be 1.035 to the t power, but you want to write it as a power of 4t, but it still has to be the same number. So we want, what could I put here and raise to the 4t power, but it still represents 1.035. So it's going to be 1.035. Now, what exponent can I give my base so that when I have a power to a power here, right? I have this power, I'm going to have a power to a power, and powers to powers, we multiply the powers. So what exponent can I give my base so that when I multiply my powers, I actually just get t? So that would actually be 1/4. Right, because 1/4 when I multiply these powers, 1/4 times 4 is actually 1. So this is still just t. 1/4 times 4, t is t. So now what you would want to do is take 1.035, this here, and plug that into the calculator because you want to simplify that. So when I plug that in, I get 1.008637446 raised to the 4t power. All right, and let's take a look at B. So I want to take 1.05 to the t power, and I want to write it with a power of 12t. So it's 1.05. I want a 12t power, so I need to have 1 over 12 inside, because 1/12 times 12 is 1, so I'm still left with t. So plug that into the calculator, this whole thing, plug that in the calculator, and you get 1.004074,124 raised to the 12t power. Okay, let's take a look at 5. All right, so number 5 says, find the exact value of the point on the unit circle when theta is 240 degrees. All right, so let's draw a picture. All right, so 240 degrees, theta equals 240 degrees. 240 degrees is in quadrant 3, so draw a picture. So here's your angle. Theta equals 240 degrees, and I want to find the point that's on the unit circle. So here's my unit circle, and I want to find what is this point where my angle terminates that's on the unit circle. So this point, remember, is x comma y. All right, so remember, another way to represent a point besides xy is cosine theta comma sine theta. Remember, x is equal to cosine and y is equal to sine. So you know what your theta is. Theta is your angle. My angle is 240 degrees. So it's cosine 240 comma sine 240. So just plug those into the calculator. Cosine 240 comes out to be negative 1/2. And that makes sense because my x value is negative in quadrant 3. And sine 240 is negative 0.8660. And you have to remember that that's negative the square root of 3 over 2. Okay, so let's take a look at number 6. Okay, so it says determine which quadrant theta lies. So notice that my angles are in radians, so I want to change them to degrees. So this theta is 180 degrees, so it's 3 times 180 divided by 4, which is 135 degrees. So 135 is in quadrant 2. And this one over here, B, same thing. Theta is 180, so it's negative 11 times 180 divided by 6. Plug that in your calculator, you get negative 330 degrees. Remember, an angle of negative opens down. So that would actually be in quadrant 1 like this. Okay, so that would be quadrant 1. So number 7 says determine the end behavior. Write using as x goes to negative infinity, f of x goes to, remember f of x is y. So as x goes to negative infinity, as x goes to the left, what happens to your y value? So the easiest thing to do is just to graph it. Okay, so let's take a look at 7a. So what you want to do is take this and plug it into your calculator and graph it and see what the graph looks like. So plug it in, and your graph looks something like this. Okay, so it's saying as x goes to negative infinity, what does f of x go to? Okay, so let's see. X goes to negative infinity means as x goes this way, goes to the left, what happens to your y values? Your y values are increasing, going up. That would be to positive infinity. Now you want to do the other side. As x goes to infinity, what happens to f of x? That's your y value. So let's look on the right side. As x goes this way, to the right, what happens to your y values? Your y values are going up to positive infinity. All right, and let's take a look at B. Same thing, draw a graph. So draw a picture. And when you graph this, it looks something like this. Okay, so we have when x goes to negative infinity, f of x goes to what? All right, so let's see. So as x goes this way, your graph goes up to infinity. Now we want as x goes to positive infinity, where does f of x go to? That's your y value. So as x goes this way, where's your graph going? Graph is going down. Your y values are going down to negative infinity. All right, and let's take a look at 8, last one. Okay, so it says determine all 6 trig functions, so that's sine, cosine, tangent, secant, cosecant, cotangent, if 5, negative 12 is a point on the terminal side of the angle theta in standard position. Okay, so let's see. We're going to draw a picture. So I have the point 5, negative 12. So first you have to decide what quadrant that's going to be in, and that is in quadrant 4. So this is when you draw your reference triangle. Remember, it always goes to the x-axis because this is your reference angle that you're going to use as your theta. All right, so my x is 5 and my y is negative 12. And what I need now is the hypotenuse. So we'll use the Pythagorean theorem. If you know the triple, you can just write it down. So it's if not, then you have to use the Pythagorean theorem. So it's 5 squared plus negative 12 squared is equal to x squared. So it's 25 plus 144 is equal to x squared. So x squared is equal to 169. Square root both sides, we get plus minus the square root of 13. Since it is the hypotenuse, though, it will be the positive root, just 13. All right, so now I want to find all my trig values. So remember SOHCAHTOA, S-O-H, C-A-H, T-O-A. So let's start with sine. Sine theta, sine is opposite over hypotenuse, so we need to label the triangle, opposite, hypotenuse, and adjacent. So this is the hypotenuse, this would be opposite, and this would be the adjacent next to. So it would be negative 12 over 13. Cosine. Cosine theta is adjacent over hypotenuse, so that would be 5 over 13. Tan theta is opposite over the adjacent, so that would be negative 12 over 5. Okay, so now we want to do cosecant. Cosecant is the reciprocal of sine, so that would be, so I go to sine and I flip it, so it would be negative 13 over 12. Secant is the reciprocal of cosine, so I go to cosine and I flip it, 13 over 5. Cotangent is the reciprocal of tangent, so I go to tangent and I flip it and I get negative 5 over 12. Okay, so that's it, and study, watch the video 1,000 times if you want, and I'll see you tomorrow in class. Have a good night. Okay, so number 9 is to write the equation of a cosine curve, and they give us the amplitude is equal to 3. The period is equal to pi over 3. And it has a range from 0 to 6. And it increases from 0 to pi over 6. Okay, so let's see. So if my range here is from 0 to 6, that means I have a midline, and the midline would be right in between here. So therefore, in between 0 and 6 would be 3. So my midline would be y is equal to 3. So that's what I'm going to have tacked on at the end, the plus 3 at the end. So I have a period of pi over 3. So remember, period is 2 pi over b. So I know this has to equal pi over 3. So what I'm going to do is I'm going to cross multiply so I can figure out what b is. So I have b pi, so b times pi is b pi, equals 3 times 2 pi is 6 pi. Divide both sides by pi, and we get b is equal to 6. All right, so now this other piece here says it's increasing from 0 to 6 pi. So remember, cosine looks like this, or cosine looks like this. So it's increasing from 0 to 6 pi. So from here, at 0, my graph is not increasing from 0 to whatever number, right? It's decreasing. So over here, my graph is increasing here. So since my graph is increasing from 0 to pi over 6, let's say here, I know that it has to start at its min. So that means when I plug my amplitude, it has to be negative. So it'll be y equals negative 3 cosine. My b was 6, so it'll be 6x. And my midline was 3. So it's y equals 3 cosine 6x plus 3. Now, I know I forgot to do 3D, so I have to go back and do 3D for you guys. So let me just move everything up. So 3D was determining the amplitude, the period, and range for g of x. So this was g of x equals 2 sine 4x. So the amplitude is equal to 2. The period is 2 pi over b, which is 2 pi over 4, which is pi over 2. And we have to have the range. So what's the midline? Well, we're adding nothing at the end. So my midline is the x-axis, y equals 0. And my amplitude is 2. So we're going up 2 and down 2. So we're going down to negative 2 and up to 2. So it'd be from negative 2 to positive 2. And the only other thing you guys need to make sure that you do know is make sure you know your growth and decay formulas. So that'll definitely be on the test. It is a word problem. You have to know them. So go back and look at your formulas. No, that's your interest. So go back and look at those formulas. Make sure that you know them for tomorrow. Okay? Have a good night.